Hello, in this video I want to share with you our vision of how Matrix products are used for teaching modern digital electronics. Our mission is to give engineers the skills and tools they need to create amazing electronic systems. And we've been in this market for around 25 years, and we sold microcontroller development systems to makers, educators and professionals. In the professional market, we supply tools to hundreds of engineers from major corporations to small one-man consultants. We've also sold equipment to some of the world's most prestigious universities and colleges, and to also many makers and students. And the great thing about being present in those markets is that we understand the skills that modern engineers need. In terms of modern digital electronics, we focus on 8 different areas, as you can see there. And we provide students with software, hardware, and the curriculum needed to gather those skills. These products are used in lots of different markets in engineering education. And this table shows you whereabouts those products are used. Starting at vocational schools, between 16 and 18, microcontroller systems are now taught in the UK across all engineering disciplines. And it's a 120-hour unit, and that's a reflection these days that there are a few mechanical systems that don't have an electronic system that goes with it, and that programming, data gathering and control are key skills in every branch of engineering. We're very strong in electrical electronics, and our more advanced courses on DSP, digital comms and FPGAs are used in electrical and electronic departments and also in communications engineering. For embedded systems, we have E-blocksro hardware and Flowcode. E-blocksro hardware is also compatible with all third-party integrated development environments like Arduino, Microchip and Expressive. We also supply curriculum, which is free of charge, available from our portal on our website. And we're very strong at embedded systems. PC app development is facilitated by Flowcode and E-blocks, and this allows students to create apps that run on a Windows PC to control and gather data from an embedded system. Moving on from that, students and engineers also want to link their mobile phone to an embedded system for control and data gathering, and web app development is also available with Flowcode and E-blocksro. Robotics is a really motivating way of learning control, and we have a couple of solutions for this. Our small Formula All Code buggy is a fantastic tool that allows students to learn robotics in a really motivating way. It's quite low cost. The learning opportunities are amazing, starting from flashing an LED through to solving quite complex mazes. It's a really fantastic way of getting a little competitive element into the classes, and students love it. We also have a robot arm, which is based on a pick that can be controlled and that can be programmed from Flowcode. Music has always been an area of interest for engineers, and we enable students at quite a low level to understand music technology using Flowcode and data flow programming and our SysBlocks panel. SysBlocks is a very powerful 32-bit microcontroller with a analog to digital converter at the front and a digital to analog converter at the back, and this allows students to quite easily manipulate signals and understand signal processing and microcontroller system development using data flow programming and flowchart programming combined. Moving on from that, digital signal processing, Fourier transforms and concepts like Nyquist and digital filters are taught at probably second year electronic engineering in universities, and the same SysBlocks panel is fantastic for teaching DSP, and Flowcode is a great software tool that allows students to gather the appropriate skills. Digital comms is a topic that is taught in most electronic engineering courses, as well as in communications engineering. And SysBlocks is designed to enable you to learn all the concepts there in traditional AM and FM, as well as in more complex digital protocols like QPSK and so on. And again, that uses data flow programming inside Flowcode. Test, control and projects are a key part of all engineering courses, and Flowcode is a great tool for that. Flowcode is compatible not only with our eBlocks hardware, but it's compatible with a huge range of third-party hardware which is very low cost, like Raspberry Pi, Arduino and DSP circuit boards that you can see there. FPGA programming is a topic that's taught in electronic degrees, and eBlocks has an FPGA board, and we use the Quartus 2 software for teaching VHDL and Verilog. Flowcode is a key part of our offering here, and it's worth looking in a little more detail at what the software is able to do. There are actually 3 different software applications within Flowcode: Flowcode Embedded, Flowcode PC Developer, and Flowcode Web Developer. Flowcode Embedded is compatible with around 1,700 different microcontrollers from many of the major silicon vendors. It has a huge range of components inside it and a huge software library. It tightly integrates with eBlocks 3 to provide serial debugging, but it also works on third-party hardware for serial debugging as well. PC Developer allows students and those in industry to create quite sophisticated applications that run on a Windows PC, and Matrix human-machine interfaces make use of PC Developer. PC Developer allows students to create PC applications that link to third-party hardware like Arduino to provide control and data monitoring systems. Web Developer allows students to create JavaScript programs that run in a browser, and these programs can enable them to link their mobile phone or tablet or PC to web-enabled embedded systems like Raspberry Pi and ESP32. So why is Flowcode successful in education? There's a problem in programming that some students just don't like and perhaps will never get C-code programming. And some of these students respond very well to a graphical method or a graphical approach of programming. And you can see here on this image that Flowcode allows students to program in flowcharts, in pseudocode or something like BASIC, in blocks, or in C-code programming, and to mix between or transfer between those different programming techniques. And in fact, Flowcode was initially designed to teach students C-code programming. In the graphical programming environment, it's not possible to make any syntactical errors, and programs always compile. And that's a huge barrier that students need to overcome. Flowcode also provides opportunities for designing state machines and for using data flow programming, which are different ways of looking at programs. So Flowcode is very successful at teaching students programming. Another key fact is that Flowcode has simulation of just about everything or every component, and simulation is a great way of learning. And for some areas like graphical touchscreen design, it's almost essential because it just saves so much time in creating electronic systems. So the simulation is really strong. Flowcode has a huge library of components and routines for sensors, displays, and other components, and all of these are validated and supported by Matrix staff. There's a really comprehensive wiki, which is available on the Flowcode website, and that's administered by Matrix staff. And there's also a forum where any user can post a problem, and that forum is manned by volunteers and by Matrix staff. There is a YouTube site for Flowcode with around 100 videos and 50,000 subscribers, and that's a fantastic tool for learning. and that's integrated now into our new learning curriculum. Let's just look at some new features of Flowcode. There are 3 of particular note: Auto ID, Web Mirror, and the WYSIWYG Display Designer. The Auto ID system allows Flowcode to know what hardware is connected to the computer, and it allows Flowcode to set up all of the appropriate components in the Flowcode environment. And that saves students a huge amount of time in terms of configuring the different hardware and the system. Configuration is a key problem for students in learning. And this is taken from the data logging market, where the data logging software knows what sensors are plugged in. So Auto ID is now available on Flowcode 11 and E-blocksro. Touchscreens are now a almost standard component in electronic systems, and students need to know how to design touchscreen and graphical display systems. There is a What You See Is What You Get touchscreen system designer in Flowcode 11 that allows students to really easily design interactive touchscreen systems for not just the eBlocks hardware, but for a large range of third-party displays as well. And that works really well. Moving on from that, students want to use their mobile phone for data gathering and control, and it's now possible to use the Web Mirror feature in Flowcode 11 to mirror your touchscreen onto your mobile phone so that you can use your phone for data gathering and control, and that works anywhere in the world, and it works over institution firewalls as well. Okay, thank you for watching.